Hey, what's up, everybody? I'm just here on the moon. Just had to get out of, uh, just had to get out of there for a little while. Just take a break, ski up here in space. So, hey, look, I figured out the Chapter 4 test. So, let's just talk about some business real quick. But I put the Chapter 4 test on my math lab, and I'm just going to make it worth 120 points this time. So no practice test like there usually is. I'm just going to put 20 extra points into the Chapter 4 test, and hopefully it should be pretty easy. So being that it's on my math lab, you'll have access to the textbook, you'll have access to the help me solve this problem, you'll get infinite tries, things like that. So I'm hoping that'll be like a transition, because for the Chapter 5 test, I'm not going to do that. I'm going to come up with a better solution for the 20 points for the practice test for Chapter 5. And I think that when we go to take the Chapter 5 test in my math lab, I'm going to do it as a real test where you're not going to have, a second try. If you get a problem wrong, it's wrong. And, like a normal test would be. So I want to transition to that using the Chapter 4 test as like, an easier one, just so we can kind of get used to it. But the Chapter 5 test will be like a real test. So let's finish up Chapter 5 today, and I will talk about the due dates for both of those at the end of the vid. So let me just catch my ride. I'm going to hop on this rocket, head back home, get on the whiteboard.
Time is X minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Oh, right. Thanks, guys. That's my ride for dropping me off. Gotta jump out of the rocket there. Anyways, let's get started. So, what I want to do today is finish up Chapter 5. It's just the last section that I want to talk about is kind of, like the big picture, which is, so, Chapter 5 is rational equations. This is what we haven't talked about yet. I'm working with rational expressions, and normally, I would do some review, but I was just thinking I'm not going to do that just because, seeing as we're recording these, you can go back and watch them. So you definitely should review the addition and subtraction of rational expressions. That can come into play when you're solving equations. So there's a couple different ways to do this, but first of all, here's what we're talking about. Something like this. X divided by 3 minus x divided by 4 equals 12. Right, this is a rational equation, simply because of this. It's got an equal sign, it's an equation. It's rational because it has fractions in it. I mean, for me, like, I don't know if I would, this is really kind of a bit ambiguous because, let me just make a point really quick. I think that you could, if you wanted to, write x divided by 3 as 1/3 x, and write x divided by 4 as 1/4 x, right? And now, so I really didn't do anything other than write the division as multiplication of the reciprocal. Okay, you can always do that. But when you write it like this, you can kind of see that it looks like a linear equation. It looks exactly like a linear equation. It, in fact, is a linear equation. So to classify this as a rational equation is a little bit of, a personal maybe preference. But so what the point I wanted to make is that, to me, like, when I would call something a rational equation is when the variable is in the denominator. And that didn't happen here, so I just want to make that point. I don't know if it's even something you need to worry about. Just out of interest, there is no variable in the denominator of this equation, so I wouldn't maybe call that a rational equation, but it does have fractions, so let's just go with that. The thing that has an equation that has fractions, a rational equation. But the point is, how do you solve rational equation? How do you solve equations that have fractions in them? And there's a couple ways to do that. So one of probably the most straightforward ways, or intuitive ways, not straightforward, but most intuitive ways, is just to combine the fractions. Right? These are like terms. They both got an x, so you can combine them. If you're going to combine them, you need common denominators, yada, yada, yada. So go ahead and do that. This one you'd multiply by 4. This one you'd multiply by 3. Right, so you get 4x, whoops, 4x twelfths minus 3x twelfths equals 12. Combine these. 4x minus 3x is x. X twelfths equals 12. Now you can multiply both sides by 12 to cancel this. And you get x equals 144. Great. Now, just like every equation, you should go ahead and check, make sure that's right. You know, does this, when replaced 4x, make a true statement? If it does, you know for sure that you got it correct. So try it. Is 144 divided by 3 minus 144 divided by 4 equal to 12? Oh boy, I need a calculator for that. Hey, let's see what it says. 144 divided by 3 is 48. 144 divided by 4 is 36. 48 minus 36 is equal to 12. So that's 100% correct, right? Verified. It works when you put it in. That's the solution. That's what it means for something to be a solution. Cool. All right, so that's one way to solve equations like this, is to combine the fractions using everything that we've been talking about. But there is a much more common way to solve rational equations. I mean, it's just there's maybe I don't know if I want to say better way, but when you have an equation, you're able to do anything that you want, provided that you do the same thing to everything. And so when you have that type of like logical power, you can remove anything that you want to remove. So what I'm getting at here is you can do this thing called clear the fractions by multiplying everything through by the common denominator of every fraction. So watch this. We just found the common denominator. There's two fractions here. This one and this one. We found the common denominator. It's 12. Just multiply everything by 12. Right? Multiply this by 12, multiply this by 12, and multiply this by 12. 12 times x over 3 is 12x over 3, which is 4x. Right? This would be 12 times x divided by 3, 4x. 12 times x over 4 is 12 times x divided by 4, which is 3x. And 12 times 12 is 144. What this does is it transforms a rational equation into a purely linear equation. Looks very familiar to us. 4x minus 3x is 1x. X equals 144. Same exact answer. And it's a bit cleaner, you know. I do think that this is the best way to do it, in that whenever you have an equation that involves fractions, you can just clear all the fractions and then just treat it like a linear equation, which you should be very familiar with how to solve. And it does simplify it. It makes it a lot easier. The reason that I am even mentioning other strategies is because I feel like I've seen and noticed people having the tendency, if you learn how to solve rational equations is get rid of the fractions, I feel like that leads people to believe that they can do that always, which is not true. So let me just make a point here. This is a rational expression, and you can't clear the fractions of an expression, right? You can't just multiply everything through by 12 here, right? Because an expression is a number. If you multiply that number by 12, it's a different number. So you can't just do whatever you want to an expression. The reason that you can do whatever you want to an equation is because you're using some logic. that says, if this is exactly the same as this, then this multiplied by 12 is still exactly the same as this multiplied by 12, right? And that's logically sound. And that's the power that you have when you're dealing with equations. If this is exactly the same as this, then you do whatever you want to this, as long as you do the same thing to this, and they're still the same, right? So anyways, I've just kind of noticed, I feel like, people getting too used to clearing fractions that you do it all the time. You can only do it with equations. Okay. But when you have an equation, I think that you should totally do that. So here, try one. Let's give you a similar one here, like y fifths minus y thirds equals 15. It's a pretty similar problem, so give that a try. It might be worth it to try it both ways, but like I was just saying, here's how I would do it if I was alone, and if I'm just solving this, here's what I would do. I would multiply everything through by the common denominator of 3 and 5, which is 15. Multiplying 15 through on this side means I have to multiply 15 through on this side. So I'm just multiplying everything by 15. 15 times y over 5, I'm going to be really explicit about this, is 15 times y divided by 5. 15 times y divided by 5 simplifies to 3y. 15 times negative y divided by 3 is 15 times y divided by 3. 15y divided by 3 simplifies to 5y. And 15 times 15 is 225. I think. Probably verify that. I'm not good at head math, as you know. 15 times 15, 225. 3y minus, before I go through this, so you clear the fractions. There's no more fractions. Now it's just a purely linear equation, which, looks a lot more friendly. It's just, these are easy, algebraically speaking. And that's why so many of these strategies seek to transform something into these linear equations, because they're the backbone of all, it's just super easy to solve. So if you can make something that's difficult into something that's easy, it's a great strategy. 3y minus 5y is negative 2y. Divide by negative 2 on both sides. Y equals negative 225 divided by 2. And I'm going to leave that like that, right? I was just about to calculate it, but this is an odd number, and this is divided by 2, so it'll be something, some decimal if you divide those. So I just like to leave things as fractions. That's your answer. And I guess it would be okay to do 225 divided by 2 is 112.5. So if you wanted to write that out as 112.5, that's all right. You should go back through and check to make sure that is correct. Check your work. It's just really a good habit to always do. So is negative 225 divided by 2 divided by 5 minus negative 225 divided by 2 divided by 3 equal to 15. This right here is a little bit weird, but I'm just going to do keep, change, flip. So keep negative 225 divided by 2, change this to multiplication, and flip 5 to 1/5. Same thing here. Keep, change, flip. Makes it a little bit easier to look at. So you get negative 225 divided by 10 minus, plus, negatives plus, 225 divided by 6. Is that equal to 15? To add these together, you need common denominators. 10 and 6, so 30 will work. It's a lot of work to check. Multiply this through by 3. 225 times 3, 675 divided by 30, negative 675. This one here, you multiply by 5. 225 times 5, 1125 divided by 30. Is that equal to 15? Negative 675 divided by 30 plus 1125 divided by 30. is 1125 minus 675. That's 450 divided by 30. And is that equal to 15? Yes. Okay. Sorry, that's a long, arduous check, but I really wanted to make the point that it is a good habit to check, and sometimes it's cumbersome. Sometimes it's I mean, that was pretty cumbersome. It would make it less cumbersome if you have a calculator, a nice graphing or scientific calculator next to you that you can just do these calculations kind of quickly. And in fact, if you have like a TI-84 or a nice scientific calculator, you could have just done this without common denominators on the calculator, right, and just see if that was 15 straight away. Anyways, it works, so that's definitely the answer. Great. All right. So let's do one here where there is a variable in the denominator. I want to show you something. How about 4 divided by x minus 1 equals 3 divided by x plus 2. So it's an equation, and it's definitely a rational equation. It's got fractions. There's variables in the denominator. So, what do you do? Kind of the point here that I would really like to make, like, here is the big picture, is how do you solve these types of equations, right? And it's different than how you would solve another type of equation, like a quadratic equation or like a linear equation. I really like to tell people that really the main reason you study algebra, intermediate algebra, is so that you can know how to solve equations of different types. And part of that is being able to recognize different equations. So being able to look at this and say, that's a rational equation, and then going further to say, I know how to solve rational equations. I know what strategy to adopt in order to solve that type of equation. Yeah. So this is a rational equation. To solve rational equations, what you should do is clear the fractions. Clear the fractions by multiplying the entire equation through by the common denominator, hopefully the lowest common denominator of every fraction that's there. So there's 2 fractions here. The lowest common denominator of those 2 fractions can be found using that technique that we were talking about, right? So this is a factor and this is a factor, right? So x minus 1 is a factor of one of these, and x minus plus 2 is a factor of the other one. They don't share anything, so take them both. It's x minus 1, x plus 2. So it's just the 2 things multiplied together. That's a pretty common scenario. So rather than force these 2 fractions to have common denominators, multiply the entire equation by that. So I'm multiplying the entire equation by x minus 1 times x plus 2. Multiply that by that, and multiply that by that. And here's the cool thing about that. Here's what happens. When you multiply x minus 1 times x plus 2 by 4 divided by x minus 1, you get this. X minus 1 times x plus 2 times 4 divided by x minus 1. Why this is cool is because you got an x minus 1 on top and an x minus 1 on bottom. So those cancel. When you multiply this by this, you get x minus 1 times x plus 2 times 3 divided by x plus 2. And now you can see you have an x plus 2 on the top and x plus 2 on the bottom. So those are eliminated. Resulting in x plus 2 times 4 equals x minus 1 times 3. Separate this. So fractions are gone. Fractions are gone. That's the point. Now it's just a regular old linear equation. Distribute the 4, distribute the 3. You get 4x plus 8 equals 3x minus 3. Combine like terms, minus 3x from both sides. minus 8 from both sides, and you get x equals negative 11. 8, 10, 11. X equals negative 11. So again, you should check to make sure that that's correct. Plug negative 11 back in for x. See if you get a true statement. Right, so is 4 divided by negative 11 minus 1 equal to 3 divided by negative 11 plus 2? Is this true? 4 divided by minus 12, is that equal to 3 divided by minus 9? 4 divided by minus 12 simplifies to negative 1/3. 3 divided by negative 9 simplifies to negative 1/3. They're the same, so negative 11 is right. Awesome. So this works. Another point, I just want to make another point here that let's just, for pretensies, say that I or you flipped a negative. You get x equals positive 11. Accidentally. You made a mistake. Go back and check, when you say, is 4 equal to 11 minus 1? 4 divided by 11 minus 1, is that equal to 3 by 11 plus 2? 4 divided by 10, is that equal to 3 divided by 13? Simplify both of these, right? So this would be 2/5. 3/13 doesn't simplify because they're both prime. And these two things are not equal. So you see you made a mistake, right? If you go back to check and it doesn't make a true statement, you've messed up. So that's it, but that's informative, is what I'm trying to say. Is that that checking your work lets you know if you have A, done it correct and not made any mistakes, or B, made a mistake, you need to go back and figure out where. Yeah. Okie doke. Alright, so let me have you try one. Try 1/2. No. Try x minus 6 divided by x plus 9 equals 2/7. Minus 6 plus 9 or equals 2/7. Yeah, give that a try. So again, this is like kind of the thought process that I go through is that, make sure this is recording. What you're looking at is an equation because it's got an equal sign. It's a rational equation because it's got fractions. How you solve rational equations is clear the fractions. You can always clear the fractions, right? Because you can always multiply an equation by whatever you want. Let me slow this really far down to show you. I can definitely clear this fraction because I can definitely multiply this by what's in the denominator. So I'm just going to multiply this by x plus 9. If you multiply something by x plus 9, you have to multiply everything by x plus 9. That's just how you deal with equations. If you do something to one thing, you have to do it to everything. Right? X plus 9 times x minus 6 divided by x plus 9 cancels the x plus 9s, and you just get x minus 6. Over here, you get 2 multiplied by x plus 9 divided by 7. So I got rid of one of those fractions. Now I can get rid of the other one by doing the same thing. If I don't want that 7 there, I can multiply by 7, and that'll cancel it. If you multiply something by 7, you have to multiply everything by 7. So this gives you 7 multiplied by x minus 6 equals just what's on top. Boom. All the fractions are gone now. But just to, reverse this, usually people do that all in one step. Feel free to do it in multiple steps, right? But normally what would happen is you would identify the common denominator of all the fractions, which in this case is x plus 9 multiplied by 7. And then you would just multiply that through by everything to clear all the fractions in one go. So this would give you 7x plus 9 times x minus 6 divided by x plus 9. X plus 9s go away, and you're just left with 7 and x minus 6. Here the 7s go away, and you're just left with 2x plus 9. Bam. That's why this strategy is so nice. This is just a regular old linear equation. Distribute the 7, distribute the 2, collect like terms, blah, blah, blah. Let's follow that through. So it's 7x minus 42 equals 2x plus 18 minus 2x from both sides. You get 5x equals, add 42 to both sides. 42 plus 18 is 60. Divide by 5, and you get x equals 12. Don't stop there. Be sure that that's right. Once you've found an answer to an equation, prove that it's the solution by inputting it for x and seeing if you get a true statement. Right, so is 12 minus 6 divided by 12 plus 9 the exact same number as 2/7? Is that true? 12 minus 6 is 6. 12 plus 9 is 21. 6, 21, both share a 3, so I could factor out a 3. 3 times 2 and 3 times 7. Cancel the 3's. 2/7 is equal to 2/7. So it's right. Good. Verified completely. Awesome. Okay, so one thing here. At the beginning of the chapter, just talking about how kind of like big a deal it is that when you have variables in the denominator of fractions, you got to be on constant lookout for division by 0, because it just ruins everything. And if you're not aware of that, you can think you found the solution when in fact it causes division by 0, so it's not the solution at all. So I'll show you an example of that. How about y minus 1 divided by y minus 3 equals 2 divided by y minus 3. So, you know, doesn't look like anything is wrong with this, probably. This is an equation. It's a rational equation. It's got variables in the denominator of fractions. How you solve equations like this is clear the fractions. So identify the common denominator. It's exactly the same. It's y minus 3. So all you really have to do is multiply everything through by y minus 3. Look, here's a mistake I've seen people make before, is to multiply by y minus 3 twice. So, you know, you could do this. You could do it. You're just putting in additional things. This isn't the lowest common denominator. And it just kind of makes this more complicated than it needs to be if you did do this. So, you know, when things have the same denominator, that's the common denominator, not two of them. You don't have to multiply it by itself to get that. So when you multiply these through, the y minus 3 go away and you get y minus 1. When you multiply this by this, the y minus 3's go away and you get 2. Cool. Simple little linear equation. Add 1 to both sides. Y equals 3. Great. Now if you walked away right now and said y equals 3, you'd be dead wrong. Hopefully you can see what's going to happen. And that's why it's really important to check your work every time. Right? So you think you found a solution, right? So check. Make sure that it's right. Is 3 minus 1 divided by 3 minus 3 equal to 2 divided by 3 minus 3? 3 minus 1 is 2. 3 minus 3 is 0. Bam. Explosion. Let me make another point here too. That if you did the same thing over here, you did the exact same thing. So I've seen people argue before, no, it is right because you do get a true statement. But this is not a true statement. What you're looking at is not a true statement. And that's because you're using something that doesn't exist. I mean, I guess this is a bit of like some philosophy here, but you can't really say that two things that don't exist are the same. It just doesn't make any sense. Division by zero doesn't make any sense. As soon as you get it anywhere in any equation, stop and say no solution. This doesn't work because division by zero. If ever you see division by zero, done, over, problem done, doesn't make sense, undefined. Next problem. So yeah, there's no solution. Y minus 3 is not the right answer. There is no solution. The only solution that would have worked is 3, but 3 doesn't work because it causes division by 0. No solution. Cool. All right. Yeah, so how about this? How about x minus 2 divided by x minus 4 equals 4 divided by 2x minus 8. Give that a try. Pause it if you want. So, a couple different things that I would do here. I mean, there's a couple different ways that you could do this. When you're identifying common denominators, first of all, it's an equation. Second of all, it's a rational equation. To solve rational equations, you should clear the fractions. To clear the fractions, you should identify the lowest common denominator. Like we were talking about last time, to identify the lowest common denominator, you should factor everything always. So this one right here can be factored, which you should do. 2x minus 8, I'll do it on a new line. X minus 2 divided by x minus 4 equals 2 times 2 divided by 2, x minus 4. All right, so I'm pre-simplifying this. It's really helpful to do that, to look out for that. You can cancel the 2's. So this becomes 2 divided by x minus 4. Cool. Now you can see, hopefully, that the lowest common denominator is just simply x minus 4. So multiply everything through by the common denominator. Cancels here. You get x minus 2. Cancels there, and you just get 2. Simple linear equation, add 2 to both sides. You get x equals 4. Right on. So that's no mistakes were made there. X equals 4 is what logically you derived. But now go back and check, and you'll see it's going to cause a problem. When you throw in x equals 4, you're going to have 4 minus 4 here, and that will be 0, causing you to have a 0 in the denominator. Explosion of the universe. Can't do it. So this is not the solution after all. There is no solution. No solution. That's how it works. If you only found one and that one doesn't work, then there's none. Cool. All right. Yeah, so that's the nuts and bolts of it. There's some more challenging ones. But that really is the process, you know. It's just to recognize that it's irrational, clear the fractions, check your work, make sure that it does in fact make it true. That's it. So here, let me toss one at you. Put this 1 over x minus 2 equals 2 divided by x plus 4 plus 2x minus 1 divided by x squared plus 2x minus 8. X minus 2, x plus 4, x squared plus 2x minus 8, 2x minus 1. Great. So there you go. This one is, this is, to me, this is a really representative problem of intermediate algebra. This is like, I feel like you're doing intermediate algebra when you can solve an equation like this. Lots of things going on, lots of things that you need to know before you can do something like this. So again, here's the process. It's an equation. It's a rational equation. It's got fractions. So what you should do is get rid of those fractions. I've seen people kind of, get to this point and start clearing fractions, willy-nilly in a sense, where you could clear every single one of these fractions by multiplying through by this, and this, and this. But if you did that, you'd be putting in more than you need to. So what you should do is factor everything always, then find the lowest common denominator to clear the fractions. So this can be factored. You should factor this quadratic in this denominator. So I'm going to do that in place. X squared plus 2x minus 8 is x and x. Minus 8 should be plus 4 minus 2. So minus 2 plus 4 would be plus 2. And that would be minus 8. Was it plus 2? Yep. Great. So now hopefully you can see that the lowest common denominator is just simply x plus 4, x minus 2. So all you have to do is multiply everything through by just those two things. If you want to clear these fractions, multiply through by x plus 4 multiplied by x minus 2. That's the lowest common denominator for all three of these fractions. All right, this multiplied by the first fraction, and look, I'm multiplying both of these things by the first fraction. When you do that, the x minus 2's cancel, and you just get x plus 4. Multiply this through by the second fraction. When you do that, the x plus 4's cancel, and you're just left with a 2 multiplied by x minus 2. And multiply this through by the third fraction. Both the x plus 4 and the x minus 2 cancel, and you're just left with a 2x minus 1. Fractions cleared. Make sure this is sweet. This is just a regular old linear equation. Distribute the two, collect like terms. So you get x plus 4 equals 2x minus 4 plus 2x minus 1. Collect like terms, 2x plus 2x is 4x. Let me just do this over here. So you get x plus 4 equals 4x minus 4 and minus 1 is minus 5. Minus 4x from both sides. So you get minus 3x minus 4 from both sides equals minus 9. Divide by negative 3. X equals positive 3. Or does it? In order to figure out if it does, you should check your work. Make sure it makes a true statement. So the very last step solving these types of equations is the check. Is it right? Right? Is 1 divided by 3 minus 2 equal to, we don't know, 2 divided by 3 plus 4 plus 2 times 3 minus 1 divided by 3 plus 4 multiplied by 3 minus 2. And I'm putting the 3 into the factored form. Feel free to put it back into the original quadratic. X squared plus 2x minus 8. It's going to be the same either way. 1 divided by 3 minus 2 is 1. 3 minus 2 is 1. 1 divided by 1 is 1. Is 1 equal to 2 sevenths plus 6 minus 1 is 5. 7 multiplied by 1 is 7. Is 1 equal to 2 sevenths plus 5 sevenths? 2 sevenths plus 5 sevenths is 7 sevenths, which is 1. 1 equals 1. Great. So 3 works. 3 is true. 3 makes a true statement. There's no division by 0. That's the solution. Cool. All right. Well, that's about it, guys. That's, yeah. So you just got to practice those a bunch. And that's what the homework's for. So that's a wrap on Chapter 5. So I'll put a bunch of those, solving equations like that on the homework, and that'll be it for the homework for today. Actually, I was thinking about getting into Chapter 6. Yeah, I will. So I'm just going to introduce Chapter 6, put a couple of those kind of questions on this homework as well, and then we'll call it good for that. And then next, on Wednesday, we can kind of like really dive into chapter 6. The first section of chapter 6 is just kind of like, yeah, here's this idea, and just do some kind of easy problems, get you used to the notation, get you used to the vocabulary. So I think we could do that right now, pretty simply, and then put that on the homework, save us some time. As far as the chapter 5 test goes, we're good to go. So that's it for chapter 5. We're done. It's just those 3 sections. Like I was saying in the beginning, you're going to have a practice test, and I'm going to have to come up with a way to get you get that done, which I haven't solved that problem yet on how to deliver the practice tests. The real test, though, will be in my math lab worth 100 points, and it will be like a test in that you won't be able to access the textbook while you're taking it, and you'll only get 1 try per problem. So you have to be prepped for it. The chapter 4 test is just going to be like a longer homework assignment. So we'll kind of transition into testing like that with chapter 5. So I think what I'll do is I'll make the chapter 4 test due on Friday by midnight. So you have to complete it before the weekend. And then I will make the chapter 5 test due a week from today at midnight. So you've got an entire week to do the chapter 5 test. Only got a couple more days to do the chapter 4 test. So if anybody has questions or concerns about that, feel free to reach out and text or call or email, and we can figure it out. All right. So let me tell you about the next bit. Chapter 6. It's a pretty fun chapter. It's all about radicals, as they're called. So here's the basis for chapter 6. Make sure this is recording. Sweet. Basis for chapter 6 is this: you have been doing things like x squared equals 9. We've been solving equations like that. Maybe that's good. X squared equals 9. And so this is a quadratic equation, and you're asking yourself, what can you raise to the second power to get 9? Right, so normally what I would probably do is minus 9 from both sides, right? This is standard form and in factor, since this is a difference of squares. You get minus 3 plus 3. So x is equal to 3, or x is equal to negative 3. There's 2 solutions to this. There's 2 ways that you can square something to get 9. 3 or negative 3. So you can check this, right? You can write, is 3 squared equal to 9? Yes, it is. Is negative 3 squared equal to positive 9? Yes, it is. So, in chapter 6, what you do is you kind of like reverse this. And you just ask the question in a different way, right? You can say, what can you raise to the second power to get 9? And like I was just saying, there's 2 ways to do that. It's either 3 or negative 3. So, it's a bit confusing. It's a little ambiguous, If you want to make a function out of this question, we can't have that. You can't have 2 answers to a question. If you give a function something and you want to spit out what you would square to get that, then you got to be a little bit more specific. So this is what's happened. This symbol has been created, and that symbol is called the square root. I'm sure you've seen this before. All symbols like this are called radicals. This one is the square root. When you see something that looks like this, we've come to an agreement. Everybody in the world that's doing math has to be on the same page with what this means. So this symbol has come to be known as the principal square root. That's what they call it. And what that means is it's the positive version of what you would square to get 9. So when you see something like this, it's a question. This is really just a number that says, what would you raise to the second power to get what you're seeing in the middle? And so it's 3. or negative 3, but this symbol has come to be known as only the positive version. So the answer is 3. This is the number 3. So another point I want to make. The square root of 9 is a number, and that number simplifies to 3. A good way to maybe think about this is exactly the same thing as like 9/3. That is a number, and that number is exactly the same number as 3. So I'm just kind of drawing a parallel between fractions that can be simplified and radicals that can be simplified. It's kind of the same idea. So the square root of 9 is 3. If you wanted the negative version, then you go like this, multiplied by negative 1. You can multiply anything by negative 1. Normally we wouldn't write multiplied by negative 1, you just tack a negative sign on there. So this says the negative square root of 9, which is negative 3. Yeah. So just from the start, there's like a level of ambiguity with square roots. There's always 2 square roots. Every number has 2 square roots. There's always 2 things that you can square to get something, the positive version and the negative version. But there's only one principal square root, that's the positive version. So, yeah, I mean, you might get asked questions like this, like, what are the square roots of 16? What are the square roots of 16? So you would just say, all right, what can you raise to the second power to get 16? There's always going to be 2 things. One of those things is 4, the other one is negative 4. But if you were asked the question, simplify, that is only 4. And that's because this symbol means the principal square root, which is just the positive version. Okay. Yeah, so that can be confusing, but really what you want to do is kind of just forget about all that and start working with the symbols, and just do some kind of like work with simplifying numbers like this. Like maybe try that. Maybe try something like this. Maybe try something like this. And just kind of get used to working with these symbols. So this right here is positive 4. This right here is positive 5. This right here is negative 10. And this right here is 1. It's a really good idea during this chapter to have the perfect squares memorized. Normally, if we were in class, but I can post this to Blackboard too, I would give you a handout of the perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so forth. To have maybe like the first 12 memorized is very useful in this chapter, and as you continue in algebra. Right, so that's the idea of radicals. So what's going to happen is eventually you're going to get to the point where we do something like this, where you're taking the square root of something that you don't know yet. You don't know what you're taking the square root of yet. So one of the things I wanted to talk about is simplifying square roots. Squaring and square rooting is almost opposites of each other. I'm saying almost because there's kind of a problem. So I want to point something out here. Take 2 squared and then take the square root of that. See if you can simplify this. Start from the inside. 2 squared is 4. The square root of 4 is 2. Do the same thing for 6. 6 squared is 36. Square root of 36 is 6. So it appears that when you take the square root of a number squared, they cancel each other. That's not necessarily true, though, is the bad news. Let me show you why. Change this to -2. If you put in -2 squared, you get the square root of 4, which is +2. And -2 and +2 aren't the same exact thing. So when you do the square root of something squared, you don't necessarily get the same thing out. But you definitely do get the absolute value of that thing out. So this is a fact. This is a fact of algebra. Let me rewrite this in a little better way. The square root of something squared is the absolute value of that thing. As you continue in algebra, and if you take college algebra, or even further to calculus and so forth, this is a really good thing to remember. I mean, it's been very helpful for me. For us in this chapter, in chapter 6, we don't deal with it. We kind of put a band-aid on it. So in the very beginning of the chapter, if you read, they say this. Look, all right, yeah, this is true, but here's how we're going to fix this. From now on, from this point forward, assume all variables take on only positive values. So x can't take on a negative number in chapter 6. X can only be a positive number. And if that's the case, then this is true. If x is always positive, the square root of x squared will always be x. Okay, so that just, it's helpful. It's just a little bit helpful because now the simplifying work that we're going to be doing is even more simplified. You don't have to worry about the absolute value. So for example, do things like this. Simplify. 4x squared can be written as 2 squared x squared, which can be written as 2x all squared. Square rooting and squaring cancel each other in this chapter since we're assuming this. So this square root and this square go away. You just get 2x. Yeah, so this is the type of simplifying work that we'll be doing. Yeah, so keep this in mind. It is, it's kind of like a cheap fix, in my opinion. It's necessary. I'm not saying that I don't think it's worth it. It's like, you don't want to kind of make things too complicated while you're trying to learn an already complex subject. But I do like to point it out because, if you forget, if you get too used to the fact that we're doing this, you can go forward and be debilitated if you go on to the next class. Or it could end up being a crutch that makes it harder in the long run if you're not aware of it from the beginning, in my opinion. Okie doke. So let me just make sure now we can toss some things into chapter 6 for the homework. Oh, right. So a couple more things that I wanted to put on the homework is now looking at this type of thing. So this is a function. Now we have a function. It's a square root function. So this is what's called a radical equation. It's a radical equation with two variables, right? Because f of x is y. Let me just draw a parallel here to like a linear equation. That's a linear equation. Maybe here's another equation. That's a quadratic equation. So here's 3 different types of equations. What you do with equations with 2 variables, what you do with functions, I'll just name these different names. is you look at them. You graph them. That's what you do with functions. That's the and this is a starting point, right? Like if you're just given h of x equals the square root of x, then graph it. And if you don't know how to graph it, you can always build a table. Start picking values for x, figure out what they make h of x. Let's turn this into f. Plot a bunch of points and infer the pattern. That's how you do it. So maybe start with 0. Square root of 0 is 0. Go to 1. Square root of 1 is 1. You could go to 2, but the square root of 2 is some repeating decimal. So I would maybe pick 4 at this point, because then you'll get exactly 2. Plot all these points. 0 is here, 1 is here, 4, 2 is here. Maybe pick 9, you'll get 3. 9, 3 is here. What's happening is you're getting this slow sloping curve that goes that way. A couple things to notice. One is that you're not going to see any y values down here. You're never going to get out of a square root a negative number. And the reason is because of what we were just saying, where this is the principal square root. It's always the positive version. If you wanted the negative version, you could tack on a negative sign there. And that'll be a different graph. So that might be on the homework. Another thing to notice is that you're not seeing any x values over here. Try to pick x equals negative 1 even. Right? X equals negative 1. What is the square root of negative 1? This is a really interesting question. It's really fun to think about. I honestly like it a lot. What you're looking for here is a number that you raise to the second power to equal negative 1. That's what this question means. So, if you can imagine doing a positive number, well, first of all, there's only 2 types of numbers. There's positive numbers and there's negative numbers. And there's 0. 0 is not going to work because 0 squared is 0, so it can't be 0. You put in a positive number and you square it, you'll get a positive number, so it can't be a positive number. Put in a negative number and you square it, you get a positive number, so it can't be a negative number either. So there's no way you can do this. It just doesn't work. There's nothing that you can square that will produce a negative number. Therefore, you can't take the square root of anything that's negative. So the square root of a negative number is, let's just say, look, here's how you should say this. Here's how you should say this. No real answer. And notice that I capitalized the R here. There is no real number. And by that I mean the numbers, any number from the set of numbers that we call the real numbers. That will work here. If anybody has studied this before or is familiar, there is a way that you can do this by expanding your awareness of what it means to be a number and moving on to a bigger, more complex number set called the complex numbers. So we're gonna deal with this, and this could be dealt with, and I'll tell you about it at the end of the chapter. But for now, if you try to take the square root of a negative number, just write no real. There is nothing in the real numbers that's going to work there, because real numbers can only be positive, negative, or 0, and none of those are going to work. So we'll figure out. I'll show you the way how to deal with this probably in 2 more classes. All right. Sweet. Well, that's probably long enough, huh? Yeah, it's an hour. So I'll put a bunch of those in the homework, and we'll just jump off from there. Take both those tests, and let me know if you have any questions. All right, y'all. Later.